What I'd like to take a second to do for you here in this particular video is actually walk you through how to solve all those problems that you guys did as group work on Thursday, this past week. So the very first example, we can see that those two things are across from each other, right? Lines intersecting, those are vertical angles, which means we set these two things equal to each other. And so to solve this, subtract 5 from both sides. So 6x equals 30. And if I divide both sides by 6, it tells you x equals 5 for number 1. Here in number 2, here's this example where those two angles together form a line, or what we could call supplements. So that tells you 8x plus 108 equals 180. So subtracting 108 from both sides, that tells you 8x equals 72. Now, a quick note, some of you guys might actually start here. You might recognize this angle has to be 72 degrees. You might say, okay, well, 108 minus, or 180 minus 108, and you could start right here at 8x equals 72. But make sure we go ahead and solve this. Divide both sides by 8, which means that x equals 9. For number 3, we get a mix of both. So, excuse me, too far. The first thing that I usually look for are the vertical angles. So 2y and 118. And since those are vertical, they're equal. Divide both sides by 2, and we realize that y equals 59. And then the 3x plus 2 and the 118, those two form that line. So 3x plus 2, that particular angle, plus 118, that's 180. If I combine some like terms, 3x plus 120 equals 180. Right, if I combine the 2 and the 118, move the 120 over, I'm left with 3x equals 60, and if I divide both sides by 3, x equals 20. On to number 4. Right away we can see that the 5y and the 55 form this right angle, which means they are complements. If you'll allow me to abbreviate, which means 5y plus 55 equals 90. Subtract 55 from both sides. And that leaves us with 5y equals 35, and we divide both sides by 5. So y in this particular example is 7. And then if we look very closely, the 4x plus 11 is across from the 55. There's some vertical angles, which tells me that 55 equals 4x plus 11. So this is a two-step equation. 55 minus 11 is 44. That's equal to 4x, and we divide both sides by 4. X is equal to 11. As we keep going, these things get a little bit more convoluted, if you will. But if we just stay the course, we keep looking for our vertical angle relationships, our complements, and our supplements, we can do these. So right away, I see with number 5, here's a right angle. So I know that's 90 degrees. And we have a vertical angle right there with 10y. Right? So here we go. We've got these two vertical angles, which tells me that 10y equals 90. Pretty straightforward math. Divide both sides by 10, so y equals 9. With x, here we go with our vertical angle relationship again. Right? I'll mark it just a little bit differently. So that tells me that 6x equals 60. Here again, pretty straightforward. Divide both sides by 6. We get x equals 10. And if we can, and we look up here at z, now what you might try to do, if you can, is literally block off the left part of this with your hand, where you're only looking at this section right here. Make it simpler. Block off the 10y and the 90 and the 6x and the 60. Put your hand over it so all you're looking at is this part in the circle. And what we see is the 110 and the 6z form a line. And that tells us that they're supplements. So that means that we take 110 plus 6z, and they're going to add up to be 180. Subtract 110 from both sides. Excuse me, so 6z equals 70. Divide both sides by 6. We're going to get ourselves a nice decimal here. Not that big of a deal. We'll just round that to 2 decimal places, so 11.67. Number 6, here's that right angle. We got 2 angles, which tells me that these two things are complements. So 5x minus 4 plus the 29 add up to be 90. And you can combine like terms right now if you'd like. You can go ahead and we can move that 29 over right away. We're left with 5x minus 4, right, equals 90 minus 29 would be 61. Now we can add 4 to both sides. So 5x equals 65. And then go ahead and divide both sides by 5. And we get x equals 13. So far as we're kind of picking through this stuff, right? The algebra is getting a little bit more complicated, but it's the same principles, guys. Same thing here on the back side. Number 7, take your hand if you want to. Block off this section so you're just looking right here. What's the relationship between 2y and 80? Well, those two things are vertical angles, which tells me that 2y equals y plus 80. So to solve this thing, we need to move all the variables to one side. So I'll subtract y from both. 2y minus y leaves me with 1y, and all I'm left with on the other side is 80. So y equals 80. Now let's go back and look at this particular one. These two angles together, they're not across from each other anymore. They're right next to each other, and they form a line. These are supplements, which means 6x minus 3, that angle, plus 123 equals 180. So here again, I can subtract 123. You could have combined like terms at the beginning. I'm left with 6x minus 3 on this side, and 180 minus 123 is 57. Now, add 3 to both sides. So 6x equals 60. Divide both sides by 6. X equals 10. If you look at number 8, you get this set of what many of you probably recognize as perpendicular lines, 2 lines that form a right angle, which actually means all of these are right angles. So this kind of a problem could be very easy for us in that 5y equals 90 and 4x plus 22 equals 90. Now another way to look at this, right, we have vertical angles right here as well, right? The 4x plus 22 and the 90 are vertical angles, and then the 90 and the 5y are supplements. So 90 plus 5y equals 180, but as soon as you do that first step and you subtract 90 from both sides, you're left with 5y equals 90, which is where we started right there. So a couple quick steps. 90, divide both sides by 5 here. So y equals 18. To solve for x, subtract 22 from both sides, so 4x equals 68. Divide 68 by 4. That tells you x equals 17. 2 more problems. Again, with number 9, things look all complicated and convoluted, but if you want to, just block all this out. Take your hand and cover that up, and just look closely right there. And sure enough, those two form a line, which means we're looking at supplements again. So 100 plus 10y equals 180. Make sure we see that 100. So how would you solve it? We need to move the 100 over. So we're left with 10y equals 80. Divide both sides by 10, so y equals 8. Now let's come back and look. If we kind of block out the top part now, we see really we just have some sets of vertical angles. So 45 will go with 9x. So 45 equals 9x. Divide both sides by 9. We end up with x equals 5. And then the 4z plus 15, that's the same as the 6z plus 5. So let's set those two things equal to each other. So let's start moving things around. We'll move 4z over with the 6z, so let's subtract 4z from both sides. So 15 equals 2z plus 5. Let's move the 5 over with the 15. And 10 equals 2z. And if I divide both sides by 2, we realize z equals 5. And then finally with number 10, there's that right angle again, which tells me these two things are complementary. So 8x plus 2x equals 90. So going combined like terms, 8 plus 2 is 10. So 10x equals 90. Divide through by 10, which means x equals 9. This last one, kind of a challenge just to see if anybody come up with it. But if in a pair of supplement angles, one is 3 times larger than the other, you end up with 35 and oh, excuse me, not 35, 45 and 135. That's where the 35 was coming from. At this point in the course and whatnot, you probably just have to keep kind of playing around with it. The big thing to recognize, right, again, supplements, that line, that word I'm underlining, they should add up to 180. So just kind of play around with it, guess and check, and you'll get there.